Elon Musk didn't just unveil a faster motor. He quietly crossed a line the entire auto industry was pretending didn't exist. For decades, electric vehicles competed on the same axis: more range, faster charging, slightly better acceleration, incremental gains wrapped in marketing language. Every company told the same story in different fonts. And then Tesla introduced a motor that doesn't belong in that comparison at all. Because once you understand what this motor actually does, physically, mechanically, economically, you realize something uncomfortable. This isn't an upgrade inside the EV race. It's a motor that makes the race irrelevant. Not because it's electric, but because it breaks the limits electric motors were never supposed to cross. And that's why this moment matters more than any battery announcement, any design refresh, or any price cut Tesla has ever made. This motor doesn't improve the industry, it destabilizes it. To understand why, you have to forget everything you think you know about electric motors and focus on the one constraint no one could solve: rotation. Every electric motor lives and dies by how fast it can spin. Torque, efficiency, power density, cooling, longevity, they all collapse into one brutal physical reality: centrifugal force. Spin a rotor fast enough and the material wants to tear itself apart. That has always been the ceiling. Traditional high-performance electric motors begin to fail structurally around 16,000 revolutions per minute. Past that point, heat builds uncontrollably, metal expands, tolerances collapse, and efficiency plummets. Engineers don't push past it because they can't, not without sacrificing reliability, lifespan, or cost. That's why the entire EV industry quietly agreed to stay under that limit. Tesla didn't. Instead of trying to cool the motor harder, reinforce it heavier, or limit it through software, Tesla attacked the problem at its source. They asked a question no one else wanted to answer. What if the rotor didn't expand? What if the force that destroys motors was locked in place? That's where the carbon-wrapped rotor comes in and why it's so dangerous to competitors. At the center of Tesla's new motor is a rotor wrapped under extreme tension with carbon fiber. Not as a casing, not as reinforcement, as a structural constraint. Carbon fiber behaves differently than metal. It's lighter, stronger under tension, resistant to heat deformation, and critically, it does not expand the same way under rotational stress. By compressing the copper rotor inside a carbon fiber sleeve at enormous pressure, Tesla created a rotor that resists the very force that limits all others. Instead of expanding outward as RPM increases, the rotor stays locked in shape. That single change breaks a rule the industry treated as immutable. Suddenly, RPM ceilings disappear. Tesla's motor doesn't top out at 16,000 RPM. It spins past 20,000. And that number isn't marketing fluff. It's foundational. Because once RPM climbs that high, everything else changes. Power density increases without increasing size. Torque delivery becomes immediate without thermal penalty. Efficiency improves instead of collapsing. Weight drops instead of rising. This is why one person can lift the motor by hand, yet it can launch a 2-ton car to 60 miles per hour in under 2 seconds. That's not a party trick. It's a structural advantage. And it's why calling this just another electric motor completely misses the point. Most EV motors are constrained designs. Tesla's is a released one, and the effects ripple outward. Acceleration is the most obvious result, but it's also the least important. Yes, this motor enables brutal performance. Yes, it humiliates combustion supercars that cost 10 times more. Yes, it delivers sub-2-second launches with no gear shifts, no lag, no drama. But performance alone doesn't end industries. Efficiency does. The hidden cost of high-performance electric vehicles has always been energy loss. Push them hard and range collapses. Heat builds. Cooling systems grow heavier. Batteries degrade faster. Tesla's motor flips that equation because higher RPM doesn't create inefficiency, it reduces it. The tighter air gap between rotor and stator increases magnetic coupling. The lighter rotating mass reduces inertial losses. The stability of the rotor eliminates vibration-induced waste. The result is a motor that converts more electrical energy into motion, not heat. That's why a car producing over 1,000 horsepower can still deliver real-world highway range numbers that embarrass weaker competitors. And that's the part legacy automakers are struggling to explain. Because they're trapped in trade-offs Tesla no longer has. They still have to choose between speed and range, between cooling and weight, between cost and durability. Tesla removed the choice. And when engineering removes trade-offs, business models collapse shortly after. This motor isn't just faster, it's cheaper. That may sound counterintuitive. Advanced usually means expensive, but Tesla's design reduces material complexity rather than increasing it. Fewer rare earth elements, less silicon carbide, smaller housings, simpler cooling cooling, and critically, fewer failure points. Legacy motors rely on heavy metal reinforcement, precision balancing, complex cooling loops, and conservative limits to prevent catastrophic failure. Tesla's motor doesn't need most of that, which means it can be manufactured faster, assembled easier, and scaled harder. That matters because Tesla doesn't win by inventing things. It wins by producing them at volume. Anyone can build a prototype. Very few can build 1,000,000 units. This motor was designed for the factory, not the lab, and that's where the real damage begins. Because every competitor now faces an impossible choice. They can keep their existing motor designs and accept permanent performance, efficiency, and cost disadvantage. Or they can try to copy Tesla's approach, which requires retooling factories, retraining engineers, rebuilding supply chains, and rewriting validation models. That's not a tweak, that's a restart. Legacy automakers are especially exposed. Most of their EVs are built on platforms adapted from combustion vehicles. Their factories were designed around engines, transmissions, exhaust systems, and modular drivetrains. Tesla's motor doesn't fit into that ecosystem. It assumes an EV-first architecture, tight integration, and manufacturing processes that legacy plants simply don't have, which is why so many competitors are silent.
They aren't confused, they're stuck. Startups face a different problem. They can design advanced motors. Some already have impressive performance numbers, but they don't have Tesla's scale. Producing a few thousand motors is not the same as producing hundreds of thousands with consistent quality, cost control, and supply security. Tesla does all of that in-house. It designs the motor, it builds the motor, it integrates the motor with its batteries, software, and power electronics. No supplier bottlenecks, no margin stacking, no dependency risk. That vertical integration means Tesla can improve the motor continuously without renegotiating contracts or redesigning interfaces. Every iteration compounds, and that compounding advantage is why this motor isn't a one-off, it's a platform. At investor briefings, Tesla made something else clear. This motor is not rare earth dependent. That alone is a geopolitical bomb. Rare earth magnets are a choke point in electric motor manufacturing. They concentrate supply risk, inflate costs, and expose manufacturers to trade disruptions. Tesla is actively eliminating that dependency, which means while competitors scramble for materials, Tesla can scale independently. That's not an engineering decision. That's a strategic one, and it's why this motor threatens more than performance charts.
It threatens the supply chain logic the EV industry was built on. There's another layer most people miss: reliability. High RPM motors traditionally sacrifice lifespan. Bearings wear, rotors fatigue, thermal cycles accelerate degradation. Tesla's design does the opposite. Because the rotor is constrained, vibration is reduced. Because heat is managed structurally rather than reactively, thermal stress decreases. Because the motor operates efficiently at high output, components are under less strain. This isn't a motor that burns itself out chasing speed. It's one that gets stronger where others fail. That means longer service life, fewer warranty claims, lower maintenance costs, and vehicles that age differently than anything before. And that's where the industry panic becomes existential. If Tesla vehicles last longer while costing less to build, the entire replacement cycle shifts. Competitors rely on churn, on upgrades, on short product lifespans masked by financing. Tesla is quietly eroding that model, not with marketing, with physics. This is why calling this "no more electric" actually makes sense, because Tesla is no longer competing as an electric company. It's competing as a powertrain company. Electric is just the medium. The real innovation is control of energy, motion, and cost. And once you control all three, categories stop mattering.
Gasoline engines can't compete on efficiency or simplicity. Hybrid systems add complexity without solving scale. Hydrogen collapses under infrastructure and energy loss. That leaves one path: high-density electric powertrains that are cheap, durable, and scalable. Tesla just leapfrogged everyone on that path. And the scariest part? This motor is not the end. It's the foundation. Because once you can spin faster without penalty, everything downstream evolves. Smaller motors, lighter vehicles, new vehicle formats, new manufacturing layouts. Tesla Tesla didn't just build a better motor, it changed what's possible to build next. So here's the real question, and this is where the industry splits. Do you believe competitors can catch up, not match the specs, not demo a prototype, but rebuild fast enough to matter? Because this isn't about who releases a press statement next. It's about who can survive a reset. Some companies will adapt, some will license, some will fade quietly. But the idea that the EV race is still ongoing, that's the illusion this motor shattered. The race didn't tighten, it ended. And what follows isn't competition, it's consolidation. So I want to know where you stand. Comment ended if you think Tesla's new motor just closed the gap permanently and the EV hierarchy is locked in. Comment respawn if you believe another automaker can rebuild fast enough to challenge Tesla at the powertrain level. Read the replies, because that argument is exactly what boardrooms across the auto industry are having right now. And whichever side is right will decide who still exists by the end of this decade. If you want to stay ahead of where this is actually going, not the headlines, not the hype, subscribe, because this motor wasn't the headline, it was the warning.